We have 2 weeks on the chapter. I think we're fairly good through. So let's talk about the OSI model today. And I'm really going to end up, we're going to be shorter today is my intention. I haven't even gotten on email this morning. I got here and then when I talked to Mr. Spurlock there, that when I went to sit down at the computer, I discovered it was 10 o'clock. So I didn't even log on down there. As I had collaborated last night with the operating system security class, and that ended up going an hour and a half when I went over stuff with them, which actually is stuff they're doing in that class this week. Corresponds to some of what y'all are doing this week and next week and the following week or the next few weeks. It's all combined in one chapter in their book. So I had to go through some stuff for them. So with the OSI model, and what the models do, because there's two different models, what the models do is that they're showing the way that the information is prepared, sent across the network, and then de-prepared at the other end to get it back to where it's recognizable at the other end. Because the object of the models is that as you go to send stuff, it's not just a case of you just hit send and it puts it out there on the wire and just sends it right off. There's a whole process of preparation that's got to be done before it can send it. And then at the other end, it's got to go back through and do and reverse do all of that stuff to get it to where the machine there has it in a recognizable format. If you think in terms of that, if you were going to send a package to somebody, it is similar to that, okay? So if we were going to send a gift to somebody off somewhere else, that we're going to start off with, we've got that gift sitting there in front of us. Well, more than likely, you're going to wrap that up in some nice little wrapping paper for them. Because at Christmas, when you got your different things that were given to you, they were either wrapped up for you or they were put in a bag or something. Unless Santa Claus brought it to you. That otherwise, generally, things you get that when somebody gives you a gift, they've wrapped it in some way, right? So that's one of the processes. That's the first thing you're going to do in terms of sending one off. You're going to wrap it up to get it in some nicer looking gift paper. What are you going to do next to it? You're going to put a tag on it, right? And say who it's to and who it's from. So at that point, you have encapsulated the gift into that package. Is everybody following that? And you have addressed it with a logical type address. Okay? Because all you put on there was Aunt Mary or Uncle Jim or whatever. Y'all follow? From whoever. And just put a first name on it. Okay? So that you've got it labeled according to who it goes to, but at this point, you can't take it to the post office and mail it, right? Because they're not going to know what to do with it if you took that gift like you got it at that point down to the post office to mail. If you were giving it to somebody else in your house, at that point you could put it under the tree, but it didn't have to go out, so it didn't have to leave your network, so it didn't have to have as much addressing to it. Then, what are you going to do with it next? You're going to actually wrap it again, right? Either you're going to put brown wrapping paper around it or put it in a box or something so that it's clear on it to send through the Postal Service or UPS or FedEx or whoever you're using. But you got to wrap it again. So you have encapsulated what you had there, complete with the name on it of where it was going and who it was coming from. You have wrapped that up and put that inside a package. Does everybody follow on that? That's encapsulating. You then, on that package, address it. At that point, you're going to put the physical address it's going to, because you're going to, and where it came from. So you're going to put their street address of where it goes, and then you're going to put your street address on there. So everybody follow on that? And so now it's got a physical address on it. It's now ready for you to take it up to the post office or the UPS stand or whatever and leave it with them. Okay? At that point, when they go to send it, what's going to happen with it then? Probably it's going to get set in different trays and different things and be sent on along, and may go through several different sorting centers, etc., to get to wherever it's going to. And it's going to get to the correct post office. But it's probably going to be, actually, as it goes along the way, it's going to be putting other cartons with other stuff going the same direction to the next post office area. They're going to look through it and then sort it again, ship it on out to another one as it goes along the way. So it's going to keep being looked on into to the addressing some, and then put in bins, whatever, and shipped on its way. When it finally gets to the end, when the post office it belongs, it gets it, it's going to go, oh, okay, it belongs here, and then they'll sort it out and put it for the correct carrier to deliver it. It then gets delivered to Aunt Mary's house. Okay? At that point, it's still in the brown wrapper. Just has their name and the physical address. So it gets opened up, so it's decapsulated at that point, so that that outside capsulation is taken off, and then it's looked at the inside addressing on it. Who does it belong to there? Because we got it to the right house and to the right family, but that might not be who it's actually going to. And then they look at the tag on it to see who does it really belong to. Well, it's Aunt Mary's. So they hand it to Aunt Mary. Does she know at this point what she's got? Because it's still encapsulated, right? And the Postal Service never knew all along what in the world it was they were taking, other than when you handed it over to them, they asked you, did it contain any of those forbidden objects in it? But everybody else that handled it along the way, and you might have told that clerk what was in it, but everybody else that handled it along the way had no idea what was in it, other than they knew it was supposed to be legal, because hopefully the clerk did their job. So now she opens it up. She takes the wrapper off of it, of that nicer looking wrapping paper, unwraps it, and what does she have in her hand now? The gift that you were sending to her. But notice when we did it, it wasn't just a case of you got the gift and you just mailed it to her. You had to go through a process of encapsulating the stuff, addressing it, and using both a logical address and a physical address on it. So everybody follow on that? It's going to work the same way, and that's what the model is going to show to you, is those steps is going to do. Now, to do each of those things on the networking, we're going to use different protocols to do that along the way, okay? And that's really what we're going to be doing as we go on through the book. Is basically from here on, you're going to have essentially a chapter on each of these 7 layers we're going to talk about in this OSI model, okay? Now there's a couple of chapters, we got multiple chapters on one layer. But basically, we're going to talk about a whole layer and a whole chapter from here on. But you've got to know what the model is at this point. So all the details on what each of the layers are, we're not real worried about all of the details, but just the generality of here's the layers and a little bit of what happens there. Okay? So one of the models, and there's 2 models out there that's normally used. One is the OSI model. And both of these models, and TCP/IP models, the other one, both of them are very interrelated, as we will see after we look at the TCP/IP first next week. But they're both very interrelated, so they're both doing the same thing. It's just a different concept of where they came up with it. They were both developed at about the same time, within a year or so of each other. And I'm not OSI. I'm not sure which one's really the older one, but they were both date back to about 1980. So with OSI, it's Open System Interconnection, because it was designed to work with any type protocols of you figuring of any protocols that we're using of whoever system of networking they were doing should work by this one, okay? So TCP/IP would actually work in it. Novell that we mentioned the other day works within it, and so on, okay? Apple works within the OSI, also fits in there. However, that doesn't mean those others will necessarily always work together, but it was a way for them then to figure out a way to work, because they knew where on one system this is the layer where stuff was occurring, and on the other system what occurred at the same layer, and so you could work on trying to connect those protocols because you knew what they were trying to do. OSI was developed by ISO, which we talked about the other day, mentioned a little bit. So they were the ones that developed it, the International Organization of Standardization. Okay, I told you were going to get your I's, S's, and O's all mixed up. So this is Open System Interconnect. This is the organization that did it, which is the International Organization for Standardization. And they came up with the acronym differently because they didn't want to confuse it with a chemical symbol on it when they developed it, because it was scientists were involved in creating this whole thing. So that's where they got the reverse on that, to throw more confusion into the whole picture for you. So with the OSI model, there's 7 layers. And you're going to need to know what the 7 layers are in order. So that from the bottom, that's the easier way for me to remember it, we've got a physical layer, we've got a data link layer, we've got a network layer, got a transport layer, we've got a session layer, presentation layer, and an application layer. Now, as we go on through the course, these bottom 4 layers are going to be the most important ones too. Okay? They're the ones you're going to keep hitting stuff on. The top there's not going to be as much stuff here. Okay? The application layer is the layer of the model that works with the application. But that is not the application you're using. So this is not, your web browser is not the application. That's the web browser. Actually, when you're sitting there using your web browser to do stuff on the internet, the web browser interacts with the application layer. Does everybody follow on that? So it's interacting with your applications.
What is the difference between that, the iOS, like you'll see on a mobile device? What is the difference between that and iOS that you'll see on a mobile device?
iOS on what?
On a mobile device compared to that. It's like when you're pulling up an application, installing it, it's like you have your Play Store where you can get some kind of iOS game. What's the difference between that and that?
I'm not sure on what you're talking on there.
I don't know how to explain it very well.
But this is the model of how when you go to send stuff across the internet, of how it actually sends the information and then receives the information at the other end. Okay? So the application layer,
The layers up there, do they have to be in a certain order?
Yes.
Or is it, so is application the 7th layer and it goes down to 1?
goes
Or
down
is-
to 1,
Okay.
correct. Okay. So this is layer 1. That's layer 2, 3, 4, 5, 6, and 7. And you got to know what those layers are by number, okay? Now, the acronym that I remember them by is programmers do not throw sausage pizza away. Programmers do not throw sausage pizza away. There's others out there for you also, okay, that you can use to remember by. Whatever one makes the most sense to you. But the one and that one you see pretty often. Although there's some others that I don't ever remember what in the world the little saying they've got for it is. But that one made sense to me. Because if any of y'all have ever known any real programmers, a lot of them work by themselves and will work in their cubicle by themselves and just not be bothered by anybody else, and that they're very liable to call out for pizza from Domino's or whatever to be delivered, and then they don't throw the boxes away or whatever very often and end up with a slice or whatever left in them. And there's always the joke about that you got to send in somebody in a hazmat suit to clean out their cubicle because you're not sure what's growing in there. So that's where I can remember this one from. That programmers do not throw sausage pizza away. And that's working from the bottom up. Now, when we're going to send stuff, we go from the top down to the bottom. Because at this point, it's going onto the wire. And that's wire in a broad sense, okay? That's some type of channel at that point. Could be sending it out wireless, could be sending it out by light with fiber optic, or it could be sending it across wire or whatever, okay? But when it leaves physical, it goes onto the wire. The physical is actually putting it onto the wire. So application is the point where whatever application is being used interacts with the networking card, okay? And this is the things that are going to happen within the networking area. So now it's left the regular processor and it's gone into your network processor. Presentation will take it from the format that the application gave over the information and get it into a format that the network's gonna understand. The session layer is gonna do two things essentially. No. The session layer is actually going to be used to communicate with the other end to make sure the other end is there. So depending on what way we're sending it, it will establish that there's a connection across there. Okay? If we're doing one that is connection oriented. On the session layer, when we talk a little later more on it, it's somewhat like, the session layer is somewhat like a secretary to an executive or whatever. That if executives of big companies, they don't pick up the phone and make phone calls to other executives. They tell the secretary to make the phone call. They establish the session. They call, talk to the other secretary, and they both say the executives are available to talk, and then they transfer the phone call off to the executive. Does everybody follow on that? And then at the end of the phone call, it's very likely that the executives actually don't hang up talking to each other, but pass it back to their secretaries of check the calendar and make sure the calendar's clear for us to have another call on a certain day, or to go play golf on a certain day, or to have a meeting. Does everybody follow on that? And that the secretaries keep up with that whole calendar for them. Now, us as normal people, we end up having to play a secretary feature for ourselves also. That we have to call each other or maintain our own calendar. For a while, we had a secretary who would do stuff for me here that would do a lot of the type of work, but a lot of it I have to do now because we really don't have a secretary anymore. And I've never really had a secretary that would do any of that stuff anyway. But that's what the session layer is. The session establishes the session between the two ends and maintains it, makes sure it's there, and then disconnects it in the end. The transport layer will take that data that we want to send and break it down into manageable size. This is on it, okay? And the word's just gone out of my head and I can't think of what it is at the moment. That when it breaks those down, why can't I think of what we call that? Say it and I'll have it, because y'all are going to need to know the word, and I don't know why I can't think of the word right at the moment. Segments. Think of everything below, but I can't think of that one. So it's going to break that chunk of data that we want to send over. If it's too big for our network, it's going to break it into smaller pieces that will fit on our network. Okay? That's similar to if you were going to send something and or that they were going to move something from one place to another. If they've got to take it apart to do it, that's segmenting it to get it onto trucks or whatever. There's only a maximum size of stuff. So the transport layer will break it apart into the manageable sizes. It will also label them all, each of those segments. So each segment is labeled. That way, when it gets to the other end, it will look at those segments and know what order they belong in, put it all back together, and have one big chunk again. Does everybody follow on that? Sometimes when they want to move a historical structure, they'll take it literally all the way apart brick by brick. But they will label every brick on there before they move, as they take it apart. And when they get to wherever they're going to put the building back together, they then put literally every brick exactly back in the place it was in, because they labeled each one of those bricks. Does that make sense? So the transport layer breaks it into segments. The network layer is going to create packets. And what it's going to do there is it's going to take this segment that the transport layer had that passed down to it. It's going to take that segment and it's going to add some information to it. So it's going to encapsulate that segment into the packet. But what it's going to add on there is information about the size of the segment, what's the address it's going to in terms of the logical address, which is using the IP address. Where did it come from? Okay, so where was it originally coming from and where is it ultimately going to? Does everybody follow on that? And that's using IP addresses on there, and it creates a packet. It then passes it down to the data link layer. The data link layer actually creates frames. The data link layer also is the only layer that we will have sublayers on, so there's actually 2 sublayers here. But it will create a frame from this packet. It takes that whole packet and then builds some more information around it. Again, it puts some sizing on it, labels in terms of a checksum on it or something as a way to verify it really did fully arrive at the other end. And it puts on a physical address on it. And it uses MAC addresses for that. Now, one of the differences between these two addressing, this one, which is using the IP address, is done at the beginning and puts on there the IP address where it originally came from and the IP address of where it ultimately ends up. This one is going to put the MAC address on it. This is going to change along the way as it travels. Okay? The frame is going to change as it travels from one place to the other place. The packet is not. It will initially have on it the MAC address of where it started out from, and not the MAC address of the ultimate destination, but the MAC address of the next network device it passes through. Okay? So it's going to tell us where does it go next. Think back to the post office example I gave you a minute ago. You take it down to the post office and hand it to them. You've got an address on the outside of that package. They drop it, if you pay attention in there, if you've gone in the post office any, they drop it into different little carts they got sitting behind there usually. And one of the carts goes to Chattanooga, another cart goes to Atlanta, another cart goes somewhere else or something, depending on how big your post office is. If you got a little post office, they may all go to the same place. They may all go in one cart. Okay? But it depends on where they're going to next. Guess what? They've got a MAC address on them. That cart says it's going to a certain post office. It gets to Chattanooga, and then they send it out to a number of different post offices. So comes in there, and they drop it in different ones, and it gets put in different trucks or sent to the plane, different planes of where it's going to go to next. Does everybody follow on that? So that keeps changing as it goes along the way, that packaging. In this case, the MAC address will keep changing as it gets to the next location. It will look at it, and then it will put on there the MAC address of where it just came. It's sending it from at that point and give the MAC address of the next location on the way there. Ultimately, when it gets to the last place when it gets to the place that sends it to the last spot that then puts it on the correct machine, it will have the correct MAC address for the last spot. Y'all follow on that? The entire time these IP addresses never changed. It keeps looking at that and going, okay, that's where it really belongs to in the end, to decide what the MAC address is. Then, when it gets down to the physical layer, what the physical layer does is takes that frame and puts it out there onto the media that we're using, whatever type media we're transferring. And so it's actually putting it out onto the media. So it's sending it out bit by bit. It's not concerned with encapsulation or any of that other stuff at that point. It's just ship this thing out bit by bit. Does everybody follow on that? Now, the other end, what happens? So it goes to the other end. It gets to wherever it was going, and it's going to go right back up this whole model again. Because when it gets here, the physical layer is receiving it and puts it back together. Okay? It's received all those bits coming in, and so it receives them and knows this was all one frame I just got. It passes it up to the data link layer. The data link layer then looks at that frame and goes, okay, does that belong where it is now? If it belongs to it there, it proceeds to strip off the information and pass it back up here. It looks at it and says, does it belong here, looking at the IP address. If it doesn't, passes it back down. It again looks, puts addressing back on it, a physical addressing of where do I send it next, which may be through that default gateway, and sends it back down and sends it back out and goes somewhere else. So it may only come back up to here. It's going to be numerous times as it goes across the network. It comes up to the network layer, goes back down, gets repackaged and sent. If the network layer says it belongs here, it passes it on up to the transport layer. The transport layer, at that point then, because the network layer has stripped off the addressing on it, now has a segment, it looks at it and proceeds to put all of the segments back together into the one big chunk. Passes that big chunk of data back up to the session, which is the same thing this session layer saw coming down, if you remember. Okay? So both ends see what the other end saw. Okay? The session layer then has that whole big thing. It passes it on up to the presentation. Presentation layer changes it around from being a network item into where it makes sense back into the other, so it does a presentation on it and gets it into the format that whatever program it came from will recognize it. Passes it up to the application layer, and the application layer looks at it and hands it off to whichever program it belongs to. So if you made a request for a web page here, it went through all of this, came back up to here, and hands it off to the server here, and then the server can read it and doesn't see any of that other stuff that was all done in between. It sees purely what in the world you sent in the first place, and not with all of that other massaging, breaking it apart, putting it back together. Does everybody follow what's basically going on there?
What's that about bits next to physical wire? What is that about bits next to physical
When it
wire?
sends it across the media, it's sending it bit by bit. Okay, it's not sending a whole frame at one time. The only thing you can send across your media is it can only send a bit at a time. Because you're doing serial sending across your wires all the time. So you're sending bit by bit by bit across. You're not sending, you put the stuff back together so we can look on the wire and see that whole set of information there, but we're looking at it as from a bit spot to another bit spot. So it's sending it a bit at a time. It's not sending it in a chunk at a time. It's one bit at a time. So you're working with bits down there at the bottom. Not bytes, but bits. Okay? All right. So you've got 7 layers here. With those 7 layers, you work with on here segments on the transport layer, packets on the network layer, frames on the data link layer, and bits on the physical layer. Now I'm going to throw you one more right here just for your information. But I really don't think they'd throw it to you here in the book at this point. I'll go over to this side and do it. And I've got a chart. I don't remember if it's sitting in y'all's chapter for this or not. I have to glance and see. That has all of this stuff put together in one big chart. On the network layer, the device that we use is routers. So routers work on the network layer. Everything above this, you're really working with your network card, okay? In terms of the network processor. Let's put it that way. All of this stuff's happening in the network card. And actually, we're going to talk about network card more specifically down below. On the data link layer, you're working with switches. Now, there's some other devices we'll mention also can be on these, but it really comes back to its routers and switches. And then on the physical layer, your network card actually falls there. Your network interface connect card, okay, or NIC. Actually, it falls down here and on the bottom half of the 2 layers that are sub-layers that are there. But the NIC is involved on the physical layer because that's when you're actually putting it out through your connection, where you plug the wire into your computer, or picture it as the antenna if it's a wireless, okay? That's when it hits that. So it's hitting whatever your network connection is. So those are your devices that's working with layer by layer. Those are the devices that work on those layers. Now let's say the NIC you will actually see also on the data link layer where it's on, because it's got sub-layers there, and the bottom sub-layer actually is physical stuff, and that we'll see that's a MAC sub-layer. There's a bottom one. Why my mind go blank on the top one. Logical link. So you got the LLC layer, and that's concerned more, this is the software side of the issue, and this is the physical side of working with the frames at that point, okay? It's the difference is going to be on those. So you're above this point, everything is software. From that point down is all you're dealing with the physical, getting it out there on the wire. So the bottom 1.5 layers is all physical type stuff. From there above, it's more of a software type thing inside. All right, questions on all of that? That's a lot of information right there. You do have to know the order of those in, okay? They number from the bottom up, okay? That little saying I gave you there goes from the bottom up also. Programmers do not throw sausage pizza away. When you go to take the test, what I would tell you to do, I would encourage you to do, which is what I did when I was first learning networking and when I took my initial networking certification test. and I might have even done it when I did Network Plus last year, I can't remember, is remember on my directions on your test says, after you put everything away, you can have a piece of paper there and something to write with. And before you go ahead and start on into the test then, write down on that piece of paper your 7 letters. You may write it out as words, you may just put letters. All I put was letters to myself. Something to remind yourself, here's the order these 7 come in. Y'all follow on that? Because otherwise, you're going to get to question number 10. This is just hypothetical, because I haven't looked to see what y'all's actual questions are. And it's going to ask you, what is layer 4 of the OSI model? And by that time, you've been looking at protocols and other stuff through and everything, and you get to that one and you go, what was layer 4? Is layer 4 network or is it transport? And you're sitting there going, which one is it? Y'all follow with me? And if you, because you've got all of that other stuff's gotten mixed into your head by now that you've read those other questions, and you're mixing them up. And that will then get you where you can get it correctly. Okay? Same thing will go, just like I just said, on certification test. That if you're taking a networking certification test, and for sure the first time or two, or that you haven't done this a whole lot, I definitely do the same thing. I say when I did Network Plus originally, that's what I did. When I did Microsoft's Networking Fundamentals exam, they don't have anymore, that was what I ended up needing to do also. I didn't do it the first time I took that exam, but it did the second or third time, and I passed it on the third. Okay? But you will confuse yourself there on it. Now, whether or not I ended up totally confusing myself, I don't know, but I sat there and wasted time trying to remember what it was. And y'all know where you're on time limitation doing those tests now. And on certification exam, you got the same issue. Okay? Besides the fact, trying to figure out sometimes what are they really asking you. Because usually on certification test now, they're not going to ask you what is layer 4 and then give you 3 of these and some other word mixed in there. Okay? Because they'll throw something else in there that sounds similar, but it's really not a real layer. But they'll for sure have a couple of wrong layers listed for you, and then something that it's not even a layer. If you remember what all 7 layers are, you can throw that answer out right off the bat. Okay? But they'd probably ask you, if they were asking you what is layer 4, that, and that's probably 3 of your answers. For sure, if they're asking you layer 4, that if they ask you layer 3, not layer 4, layer 4 doesn't work as good. If they ask you layer 3, they're for sure going to ask and have their network and session. For the fact if you get confused on which way you count it, from the top or from the bottom. Okay? Then you always count from the bottom on these layers. So just be aware on that one. Okay? All right, questions on all of this. I've thrown you a whole lot of information right here. Okay? TCP/IP is going to be similar, but it has some differences that'll confuse things. And that's why I'd rather wait till Monday to go over TCP/IP. Let this one settle in your mind first. Because we're going to discover that there's some words between the two that don't match up correctly. Okay? And if you get this down, along with the TCP/IP model, and know what protocols are, and what we're going to talk about, notice right here we said IP right here. Guess what? We're going to use the Internet Protocol. That protocol is used on that layer. So we're going to go on further, and we're going to see where there's certain protocols are used on certain layers. Okay? Transport layer you're gonna see that that's where we use the TCP. Remember, that's what the T and TCP is, although I said it wrong the other day, because I said transmission instead of transport. Okay? The TCP and UDP occur on that layer. So we're gonna find that out as we go further along. Now, are any of y'all in Blackboard right now in the chapter? Look and see if I've got handouts in there. Go into chapter, so go down there in chapter 3, where you were. Yeah, that summary, click on the summary right there. It should be a spreadsheet type thing. Yeah, that should be it. It's a Word document, but it's really a spreadsheet. Yeah, there. Notice that if you look on the OSI layer and then you look beside it on the data frame, that's the same stuff I just gave you up there on the board. And then where I just said about a couple of protocols on the stuff. So that gives you some key things there, okay? Summarized in one chart, along with TCP IP is in that chart too, but we're not talking that today. Y'all see on what I've done there for you? And I gave you the mnemonic. I said acronym earlier. Mnemonic is actually the word you used. I gave you the mnemonic that you need to know also. Okay? So that really summarizes what we have talked for the last 50 minutes about and what we're going to talk about on Monday. And then we'll put together, and I'm going to talk a little bit further between the two at that point too. Any questions? You all got it?
It won't allow me to open up the document or print it.
Hmm?
It won't allow me to open up this document.
It should. It's open for him.
The OSI one. I'm getting this, but it's not allowing me to open it.
All right. First thing is it should go ahead and just download it. Because you should be shoving it right in Word for you. All right. Click back.
That.
All right, click it again. There, it's downloading right now. If you can click that, it will open it. That's weird. Doesn't look like you got Word installed on your machine, or it's not associated. Oh, did it right in Word for you?
No, we don't have to turn
Huh?
on.
You'd have to, some computers don't have Word, I think.
Some
Yeah,
of them don't have Word on them?
yeah. You'd have to use like an online version of Word and then open it with that if you want to.
They should all, you should have Word on every one of these machines. Because all of Office should be sitting on every one of these machines.
Just goes straight to Word.
Go to the Start menu. Go down to Microsoft Office. I think it's in.
Yeah, see Microsoft Office.
Okay, go all the way down to the bottom now. Let me make sure. That is crazy. They're supposed to have Office installed on every one of these machines. I'll have to report
The way to do it though is,
Huh?
you know, there's like an online version of Word or whatever. You could just open it up for that. and
But
print it.
y'all are supposed to have 2016 sitting on every one of these machines. Every machine in the school should have Office 2016 on it. Okay? Yours has got it on, because you got it open. And see, you got all that other stuff sitting there. Okay? He doesn't have, and he didn't have. Okay? I'm gonna have to file a ticket on that. I don't know how they did that, but these are supposed to be all using, every machine in here is supposed to be using the same image to start from when the machines start up. And the Office should be installed on every single machine in here. Weird. And that it's not a case of you could uninstall it because These are all using images off of the server. And so when the machine is restarted, it goes back and grabs that image again and sticks it back onto that machine, back like it was initially. So that makes no sense. So I will report that all of these machines need the correct image put on them. They all need Office on them. All right, any other questions? That was a good question. And that's not something, and since I can't log on to your machines, I would never know it anyway. And who knows, that may relate back to the problem we were having the other day, where y'all were having some, and he may have, remember, he sat down on that machine and worked on that machine when he was trying to get where we couldn't get to the other web pages and stuff.
He still couldn't get in afterwards.
Huh?
I still couldn't get in afterwards, but he said he'd have to fix it.
Because he said he thought it was a DNS issue, which is back to the server or a server on another campus, okay? And he may have pulled the correct image on your machine while he was sitting there doing stuff, but in any event, it's on some of these machines and not on some. All right, any other questions? If not, I'm going to let y'all go, and then I will see you Monday morning.
I just got a personal question.
Okay?
What do you think about the cloud computing?
The what?
Cloud computing, how it's advancing?
Is there, I don't see us going totally cloud, okay? That will stay hybrid cloud. How well the cloud, how popular the cloud will stay, and et cetera, I'm waiting to still see on when some bad things happen. So far, nothing bad has happened on the cloud.
They're still trying to figure out a way to like protect it, really.
That's where my big issue with the cloud is that most of the cloud providers are not backing up data that's out there unless you pay them extra for it or unless you're on a premium thing. The cloud works wonderful, okay? The cloud is great on doing some stuff. Email has gone to the cloud for a number of years, okay? Made email work a whole lot better because I can sit here and check my personal email here at school, or y'all can check your personal email here at school, assuming that you can get that application to work. But assuming that it does, that or that URL to work, that you can check your email from wherever. So I can sit here and check personal email on the school, on this computer, walk down the hall, check it down there, check it on my phone, whatever, because it's all sitting out there on the cloud. A lot of data kept out there on the cloud, and a lot of organizations putting a large amount out there. However, when you're putting the data out there on the cloud, you're then dependent on your internet connection working. That you're not, if the internet connection goes down and you've got everything stored out there on the cloud, you can't do anything then until the cloud works again. Applications can be out there on the cloud too, with the Office 365 we were just mentioning a moment ago being an example of it, okay? Because that's Office on the cloud is what it is.
I saw some prototype devices where they don't have any operating systems, that the operating system is in the cloud, and the device will connect to the cloud.
You can go 2 doors down, and every computer in that classroom that students are using is doing that. They're all virtual machines
Wow.
sitting there. All you have got in there is just a little box about that big, that thick, that's stuck up under the desk. It goes down to the server. When you turn that thing on, it goes down, accesses the server to load for you, and runs from there. The storage is all down there on the server. It's not on your device there. Okay? And it comes back, gives you an image for you working with on there. In here, y'all still got all individual PCs. Okay? Although we are pulling an image for these PCs off of that server also. But if we lose the network connection in here,
We still got the,
it's still got the last image on there and we can still boot up and run. That room, if we lose the network connection down to downstairs, nothing's going to happen. You're just going to get an error message. The cloud works neat for doing a lot of storage type stuff. You can build machines out there on the cloud, so you can have virtual machines running out there on the cloud on Amazon Web Services, Azure, Google, whoever. Amazon Web Services is the biggest one by a long shot because they got like 40-50% of the market or something. It's a large amount of the market. Azure comes in next. And actually, where y'all got the Imagine program that y'all can get stuff from, it's now moving into using Azure with it, and it's going to provide some Azure stuff, and it's changing the name of it to Azure Development Services or something as of tomorrow. My concern with the cloud is, back to what I started with, backups are not done unless you pay extra for the backup with most of the services. Large number of companies and individuals are storing all of their stuff out there on the cloud and not keeping a copy on their own local premises or somewhere else or backing up to another location. And so it's not backed up.
so I mean.
The
but
day that
sure,
something happens to one of those major data centers, and like Amazon scattered on 25 or 30 data centers through the world or something like that. When I was taking a course at Christmas, we were using Amazon Web Services out of Singapore because that's where Palo Alto had elected to put our course materials. In here, I'm not sure. Actually, when y'all are on Cisco on Netacad's actually running on Amazon Web Services also. I'm not sure which. I think they're actually running it on several locations. But the day something happens to one of those major data centers, okay, there's going to be a large number of organizations are all of a sudden we're going to go, whoa, we just lost everything. We have no records anymore because they don't have a backup of it. There's been an emphasis of my part on local people need to, even before we went to the cloud, trying to convince people they need to back up what they had on their local computer. But all of y'all know our individual computers fail at some point, right? And you need a copy of everything you got on there somehow. You may not have copies of the programs and stuff because you can go out and get another copy of that or whatever, but your data, you need a copy of that data. Does that make
Got
sense?
my external storage devices at home.
So you need to be, if you're storing stuff out on the cloud, and the cloud may be your backup, or the cloud may be your primary spot of where you're storing, okay? But it needs to be in turn, because now, where people get confused is that they see where the cloud providers will tell you that they are keeping have got it duplicated within the data center to make it run faster and to make sure if one device goes down, they keep right on working. But they're not duplicating it outside of the data center unless you pay them extra, and Amazon will do that. Azure, Microsoft Azure will do that for you, but it costs you more. And if I was a terrorist, which I'm not, but if I was one of them, the place I would be looking at to attack countries or the U.S. now wouldn't be going and doing things they've done before of blowing up certain buildings, but when they took down the World Trade Center, it was a similar concept as what bin Laden's concept was there, is I would attack one of those data centers, and they're known where they are. They keep them semi-secret, but they're not really secret. Because y'all all know where they're building the one over in Alabama right now. Okay, or you may know that they're building one at the old electrical plant over there that Google's taken over. Either Amazon or Google has taken over and is converting into a big data center. Up there in Northern Virginia, there's a major one in Fredericksburg, Virginia. It's not marked, but everybody around there knows that's Amazon's data center. And everybody knows there's one in that area. And you can find it. It's not top secret information. It's not something they go out and publicize, so if you drive by it, there's not going to be a sign in front of it telling you this is an Amazon data center. But there may well be some Amazon signs around for it. And that normal people just looking at it would think it was another distribution center or something. Well, it is a distribution center, but it's distribution of data, not packages. Okay, but it's a similar size building or bigger. Y'all follow on that? And windowless, just like the distribution center up there above Chattanooga. If you took out one of those, you're going to stop a large number of companies in the U.S. or if you took out in other parts of the world, and some of the U.S. companies are using other centers, other locations. Like I said, Palo Alto, it was cheaper for them to put us onto the Singapore center than the others, because actually what Amazon charges you on your storage fees varies according to the popularity of a data center. Does that make sense? So their rates vary by data center and by what you're storing there too. But you need to have it backed up. I keep all of my pictures out on Shutterfly. That is on the cloud. They've got their own cloud storage, okay? And have had since 1998, I think. And they've got several different storage centers for it. But all of my pictures are sitting out there, or once I get them edited and put them out there, because I've got stuff I've shot since summer. I haven't got finished editing and I haven't uploaded there yet. And if y'all go to my Shutterfly page, you can see everything I've uploaded out there. If you go to dwightwatt.shutterfly.com, you can see essentially everything I've shot since 1999, 98, somewhere back in there. Okay? Everything I've done digital. And even stuff I didn't do digital, that I used some processors back then that scanned my pictures for me as they developed them. So there's stuff from the late 90s, that was where it was done both ways, and where I got negatives sitting at home for them. But the digital stuff I've also got all stored on my computer and on my external hard drive. Does that make sense? And every week I actually copy that stuff from, I really work more off my external hard drive than my internal one. So I'm backwards on that, because normally you'd think your internal one's your primary and your external one's your backup. I really work off the external one essentially now. The programs are running on off the other one, but my data's all sitting in both places, and I copy it from one to the other every week. If Shutterfly did go out, that their center messed up, and storage devices will fail. They're using the same thing as we're using on our PCs, just on a large scale. That they're using large hard drives, etc., all stored through there. They're switching some of that stuff towards the solid state ones, but y'all know the difference in price between solid state and a regular hard drive. So either one's going to fail. There's a limited life on solid state drives, just like on hard drives, okay? That hard drives wear out, solid state drives can only be written to X number of times, 100,000 or something, okay? They're gonna fail. So there's that part on it. There's also external problems to it. I have watched companies go bankrupt that did not have their data backed up, and their main building burned down, their business building burned down, and their data within it burned up. They had no way of knowing who owed them money afterwards. And how many of you would pay bills that you don't get to receive a bill for. Occasionally there is somebody, okay, that they'll go ahead and send a pay on it. But most people and most organizations don't pay until they get a bill. And if the organization doesn't know you owe them any money anymore, they can't collect it. And so there's the problem on that. And so like I say, I would fully expect at some point a terrorist attack to be done on those. The other part is it might not be a terrorist attack. Now they've supposedly built them, and you can build these to make them fairly secure on stuff, that they're built to be able to withstand different storms, etc. And actually are supposed to be, in a lot of cases, designed to withstand some type of attack onto them. When I worked at PMSC in Columbia, South Carolina, we were actually a cloud provider for insurance companies. We actually were software for insurance companies, and then they could actually keep all of their data and use our machines at our center. And we had a data center built there outside of Columbia, South Carolina. It was designed actually for a nuclear attack on Columbia, South Carolina. If a bomb was dropped in the middle of Columbia, of a certain size nuclear bomb, supposedly it wouldn't hurt this building. They had 2 huge generators built into it that were actually running off tractor motors with, I can't remember how many thousands and thousands of gallons of diesel fuel stored there, so that they could run for 2 weeks with no power. When Hurricane Hugo went through in '89, they said, and that wiped up a lot of South Carolina, they said they went without power for almost 2 weeks and were trying to figure out how to get the diesel fuel to the place, because they were just about ready to run out, but they kept running the whole time. It was a secure building that we had to use our badges to get into there, etc. It also had sleep facilities, etc., for the operators in there. When something did happen, that they could continue, they could stay there for a number of days. So they had food, etc., kitchen for them, and sleeping facility for them, that they could keep right on working on. And that's what these others have got built on them, although I've never been into one of Amazon's or Google's facilities. But I know from descriptions of what they've described on them. So the cloud's got a huge potential out there, but it's not going to be the way everything's going to go 100%. Does that answer your question? So there's lots of potential for it, but there's also that people aren't totally preparing for the downside that could be there too. And that's an important one to it. All right, who came in late? I need to mark y'all here.
I did.
That was late.
Just a moment. I got to log back on because it. And those of you that didn't come in late can go ahead and walk out. But those that came in late need me to mark you here because my machine has locked itself. All right, Jesse, did you come in?
Yeah, I came in late.
Okay. Tavian?
Yeah.
Okay. That means everybody was here.
Do we have, we're on chapter 3, right?
Mm-hmm.
Do we have the chapter test this week or next?
Chapter 3, we've got 2 weeks on it, so the test is not due until
Next week.
not this coming Monday, but the following Monday. So on
Because
February
I
the
opened
11th.
it up and it didn't have the chapter test itself
Huh?
inside. You know, inside of Blackboard,
Mhm.
I went into the test section that you have and it doesn't show the chapter 3 test in there.
Okay, then I need to fix that still. I thought I had said it, but I may have missed it. So I'll have to check that.
Alright.
Okay?
Yeah, but you know the slips.
But I know it's set there in Medicaid. But you don't want to do it until late next week.
Alright.
Okay?
I was just making sure you were thinking.